All right, ladies, here's what I'm going to ask you to do. Can you take out your notebooks, and we are going to look at another example of graphing with negative values. All right, so get out your notebooks, hit pause on the video. All right, so what I want you to label your notes as is review, or actually, let's call it extension 6.1 through 6.3, because we're really not reviewing. Let's call it extension 6.1 through 6.3, right? And really the goal of this is I want to be able to graph. So to graph an exponential equation over the domain -2, -1, 0, 1, and 2. All right, so we're going to be graphing an exponential function over the domain of these values. All right, so let's first talk about the word domain. Domain represents my x values, right? So really what this is saying is I want to graph using a table where the numbers are -2, -1, 0, 1, and 2. Easy enough. All right, so let's get an equation going on here. Y equals 2 parentheses 3 to the x. All right, guys, see that? All right, so here comes my table. X, Y, we're going to go -2, -1, 0, 1, and 2. So the best approach to conceptually understand what you're doing with the negative exponents is actually to graph the positive values first. So what I'm going to say to you is start here. So start by substituting in the 0 value or identifying the initial value. So start by identifying the initial values. Okay, so let's see here. So in this equation, my initial value is a value of 2. Okay, and then what happens? So the growth factor is by 3. So that means I'm going to multiply this value by 3 each time, right? So 2 times 3 is 6. 6 times 3 is 18. So we can give this a little bit of steps. Step 1 is identify the initial value. Step 2 is to multiply by the growth factor. Multiply by the growth factor. And I'm going to put in parentheses decay factor because you can multiply by a fraction as well. All right, so now I need to figure out what's going on with the negatives. So if I'm multiplying this way, then if I'm moving backwards, look, I'm actually dividing. So I divide by 3, I get 6. I divide by 3, I get 2. I divide by 3 and get 2/3. I divide by 3 and get 2/9. If you prefer, so preference-wise, if you prefer, you can even think about this in decimals. And on your test, you are 100% going to have your calculators. So I'm just going to recopy this to 1, 6, 2, 18. So if you prefer, you can use your calculators. And when you divide by 3, that gives you 0.6. And when you divide this by 3, that gives you 0.2. Easy enough? All right. So negative exponents are really just about moving backwards, right? So it's creating the trend backwards in time. So if I want to graph, 3. Let's get our step 3 in here. So our step 3 is to move backwards by using the opposite operation. So move backwards by using the opposite operation. All right, so here we go. Let's graph this thing. Now, in your notebooks, I'm going to ask you to make 18 lines. So you're going to make a huge graph. On your test, I'm going to give you a great graph that you can use. But I want you to make 18 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going all the way up here. All right, so 1, 2, 3, 4, 5, 6, oh my gosh, 14, 15, 16, 17, and all the way up there, 18. 1, 2, we got 0 here, a -1 and a -2. All right, so to graph it, I'm just gonna plot these points. So at 2, I'm at 18. At 2, I'm at 18. At 1, I'm at 6. At 1, I'm at 6. At 0, I'm at 2. At -1, I'm at 2/3. And then at -2, I'm at 2/9, a tiny little fraction. So here is my graph. Now, I want you to think about this. So this is your conceptual reasoning. If I continue moving backwards, what's going to happen to this decimal or to this fraction? As I move more backwards, that fraction is getting smaller and smaller and smaller. So although it will never hit 0, I'm going to get really close to nothing because I'm continually dividing by that actual value. So that's the big conceptual reasoning on this, is that as I move more negative, my graph is getting closer and closer to 0. So as I move more negative, my graph is getting closer and closer to 0. All right. So the very last thing I want to kind of give you to puzzle around is like your big idea, you can call it. So here's your big idea for the moment. If I said to you, explain to me why 2 times 3 to the -3rd is equal to 2/27. So 2 times 3 to the -3rd is equal to 2/27. Could you do that? So think about what a negative does. I would like to encourage you to pause it here and have a conversation with somebody sitting next to you about why does this work? I want you to think about it for yourself. And yes, I'm going to explain it to you on this video, but take a moment and see if you can figure out that bit by yourself. All right, so why does this happen? If you think about it, as I'm moving negative, this is representing a constant division by 3. Or if we want to think about, instead of division by 3, we can think of this as being a reciprocal of 3. It's multiplying by 1/3. When I move backwards, 18 times 1/3 gives me a 6. 6 times 1/3 gives me 2. 2 times 1/3 gives me the 2/3. So if I'm looking at this, I'm multiplying by 1/3 3 times. All right, so this is essentially the same thing as 2/1. So I have 2 over, what do you know, 27. Negative exponents are like multiplying by reciprocals. All right, so what you're going to be working on now is a prompt, a writing prompt, a worksheet where you're going to be practicing this idea of negative exponents and graphing. And I will see you guys on Monday to study for your assessment. Have a good one.